and move on to the next problem. Number 9. Now we're dealing with a trigonometric function, which means we have to deal with a particular specified interval that does not involve infinity, because it's repeating. Now remember, sine and cosine repeat every 2 pi radians, but tangent, unlike the other 4, sine, cosine, secant, cosecant, tangent, cotangent, it is a period of pi. So negative pi over 2 to positive pi over 2 is a difference of pi units. So we're going to be using that. So we find the first derivative of this, and that's going to be 2 for that. And the derivative of tangent turns out to be secant squared x. And I'm going to rewrite that as 2 minus secant x times squared, for reasons you'll see in just a little bit. Now, that means we can go on to double primal. The derivation of 2 is 0. So we're just going to focus on the negative secant squared x, well, the negative can go down there. And we know that the derivative of secant of x, well, come to that. First of all, you got an exponent here 2. So I'm going to bring that down in front here. That's going to turn that into secant of x to the first power. And then I have to find the derivative of the secant of x within that parenthesis. And looking at your chart here for that, we are told that the derivative of the secant of x is secant x tangent x. Put it out there if you want, but make it more understandable there. So when you combine this together, this is going to be negative 2 secant squared x times tangent of x. Now, this is something that I prefer to do whenever I'm dealing with trigonometry, and you got a mixture of all these different signs, or functions rather, and particularly when you're dealing with one of the 3 minor ones, secant, cosecant, and cotangent. I'm going to change everything over in terms of sine and cosine. So we know that secant is 1 over cosine. So this becomes negative 2 times 1 over cosine of x squared. And we know that the definition of tangent is the secant, or is the sine divided by the cosine. So I'm going to put sine x over cosine x. And then I'm going to multiply all this together. And I get negative 2 on top. And then the sine of x on top with it. And then underneath it, this will be cosine cubed x. And since I'm not deriving anymore, I'm going to put it back inside like that. But you can put cosine x parentheses around it, put a cube on the outside, it means the same thing. If this is the formula I'm going to be using for determining my zeros and for determining my positive or negative values for the intervals. So, now we need to set that equal to 0. Okay? Now, what we're going to do is this, but first of all, we know that this can equal 0 when cosine equals pi over 2 or negative pi over 2, both of which are unavailable. So that eliminates any value of x for cosine being 0. So we don't have to worry about the inability of finding a 0 there. So we're just going to focus on this one right here. Negative 2 sine x equals 0. Well, again, the negative 2 drops out, so this becomes sine of x equals 0. The only time that happens in that interval is when x equals 0. Well, that makes life really easy. So that means then that we're going to have two intervals, one before the 0, one after the 0. So interval number 1 is going to be from negative pi over 2 to 0. And then interval number 2 is going to go from 0 to positive pi over 2. Since those are our limits based upon what the equation tells us right there, those are the same limits of intervals that we could not find a 0 for the denominator there. That's why they chose, one of the reasons why they chose this. Okay, so that means that we're going to test something here. So I'm going to test this with negative pi. And I'm going to test this with positive pi. We're going to test, we're in the world of ping pong. So we're going to test negative pi here. We're going to test positive pi here. And again, we're going to use that derived second derivative equation, negative 2 sine x over cosine cubed x. So negative 2 sine of x, well x is negative pi over cosine cubed of negative pi. Okay? Actually, on my paper, I'm going to have to change it up a bit. I'm going to use pi over 4. Besides, pi doesn't fit between the two. That was dumb on my part. So I'll put pi over 4 for all of this here. And that's between 0 and that and 0 and that. So that was really dumb. So anyway, so I go ahead and punch that in my calculator, and I get a value of positive 4. That means that this is concatenated on. So we'll do the same thing over here. Negative 2 sine of positive pi over 4 over cosine cubed pi over 4. And we get negative 4. So that means that this is concatenated down. There we have it. All right, so your assignment. Page 195, 2 through 10. Have fun.